All right, today's lesson is a review of the Pythagorean Theorem. This is the same topic that you worked on during weeks 1 and 2. So I just want to start off with a brief refresher. Okay, so when we are doing the Pythagorean Theorem, it only works with right triangles. So right triangles are the ones that have a 90-degree angle. Okay, when we have a triangle, the longest side that's diagonal from the 90-degree angle is called the hypotenuse. Okay, it's always the longest side. The other two are called legs. So we have a leg on that side of the 90-degree angle and a leg on this side. Okay, when it comes to the letters that you're going to use, the hypotenuse is always C. And the legs are called A and B. It does not matter which one is A and which one is the B, because they're both legs. And then we use the Pythagorean theorem that's here, and we just substitute the values that you're given into that. Usually you're missing one of those sides, and they want you to find the third side. Okay, the assignment for today is a worksheet that's uploaded on Schoology, and it's also in the document that's on Blackboard. You're supposed to do numbers 1 through 12. And then if you feel confident and you want a challenge, you can try 13 through 15. They are word problems. And the exit ticket is another problem dealing with Pythagorean theorem. I have it at the end of this video, and it's also uploaded on Schoology. That is the assignment that needs to be turned into me. If you would like me to check your work on 13 through 15, you can take a picture or upload it and send it to me, and I can check them for you. Another document that I uploaded into Schoology is the square root chart, because this will make it a little bit easier so that we don't have to keep on going to your calculator. These are all the perfect squares up to 25. If you have the square root of 49, that's the same thing as 7 squared, or 7 times 7 is 49. Okay, so if you need this one, that resource is in the folder with today's lesson. Okay, so number 1, if we're looking at this, we are given the hypotenuse, we are given C, and then we're also given A and we're missing B. Okay, again, A and B can be switched, it doesn't matter. Okay, it doesn't matter which one's which, but I'm going to use that same equation, which was A squared plus B squared equals C squared. So if I substitute my numbers in, A is 17, so I can have 17 squared. We don't know what B is, so I'm going to keep that as B squared. But we do know that C is 19. Okay, so 17 squared and 19 squared are the ones I need. If I go back to that chart, okay, 17 squared, so if I square 17, I'm going to get 289. So let's go ahead and put 289 underneath 17 squared. Okay, whoops, sorry. It is really hard sometimes to write on the screen. For those of you who have been in Blackboard sessions with me and had to do it yourself, you know how hard it is. Okay, so now we need 19 squared. So again, I'm going to go back to my chart here. 19 squared would give me 361. Okay, so if you notice, B squared is on the same side as 289. I need to get this B squared by itself. Okay, so this is just like a normal equation that you guys have been solving. So to get B squared by itself, I have to subtract 289 from both sides. So B squared equals 361 minus 289 is 72. All right, there's one more step because B is not by itself yet. Okay, to get B alone, I have to undo squaring it. To undo square, you square roots. Whatever you do to one side, you have to do the same thing to the other side too. Okay, so squaring a square, square rooting a square, cancels out and you're left with B. And if you type in the square root of 72 on your calculator, you are going to get a decimal. I got 8.49. So that is the length of this side. Okay, there's always going to be subtraction involved if you're missing one of your legs. Okay, number two. We are given both of our legs this time, but we're missing our hypotenuse. So we're given A and B, we're missing C. So again, my equation is A squared plus B squared equals C squared. So I'm going to go ahead and substitute what I know. I know A is 5. I know B is 13, but C is missing. Now these ones I like a lot better because they are quick and easy. So 5 squared is 5 times 5, which is 25. 13 squared is 13 times 13, which is 169. And we're still looking for C squared. Now notice how both of these are on the same side. Since they're on the same side, all I have to do is combine those together. So 25 plus 169 is 194. And we're in the same position we were in our last problem, where we have to undo the square. To undo the square, we take the square root of both sides. So this is going to cancel out, and I'm going to have C equals. And again, we get another decimal, so we get 13.9. So that is the length of our hypotenuse. Now, a good way to double check to see if you were right, you can substitute 13.9 back into the equation. But also looking at the picture, that hypotenuse should be longer than the other two legs. So 5 and 13 are smaller than 13.9. Okay, we're going to move on to number 3. At any point during this video, if you need to pause to try it on your own, please feel free to pause the video, try it on your own, and then come back to the video to see if you did it correctly. All right, so in this one, we have our hypotenuse right here, which is C, and we're missing A and we have B. If you want to make this one B and this one A, that's fine. It does not matter. A and B can be switched. But let's go ahead and fill it into our equation. So we have A squared plus B squared equals C squared. A squared, we don't know. B is 10. And C is 20. Okay, so I can see right away, I'm going to have to do some subtracting because there's other stuff on the same side as the A squared, and A squared is going to have to be by itself. But let's go ahead and do our simplifying. So we have A squared, 10 squared. So that's 10 times 10, which is 100. And then 20 squared is 20 times 20, which is 400. Okay, again, I want to get the A squared by itself. So I'm going to treat this just like a normal equation that we did in class in the beginning of the year. So to get rid of the 100, it's a positive 100, so I have to subtract. I always do the inverse operation. Okay, my 100s are going to cancel out. So I have A squared equals 400 minus 100 is 300. And then our last step is to remove that square by taking the square root. So A equals 17.3. And you can round these to the nearest tenth, or you can round them to the nearest hundredth. That's fine. This problem, they didn't tell us how to round it, so I just went to the tenth. All right, problem number 4. Okay, in this case, again, we're missing our hypotenuse. I label that right away because that's the longest side. And then these ones don't really matter. I can label them A or B however I want. Okay, so my A squared would be 5 squared, plus my B squared would be 14 squared, and I'm missing my C squared. Okay. 5 squared is 5 times 5, which is 25. 14 squared is 14 times 14, okay, which is 196. And I have my c squared. All right, again, 25 and 196 are on the same side. We have both legs. So those two can be combined together, and I get 221 equals c squared. Okay, my final step, as soon as I get to that point, I need to go ahead and get rid of the square by taking the square root of both sides. So c equals 14.9. Now, sometimes you will get a whole number answer. Sometimes you will get a decimal. It all depends on the problem. Okay, in numbers 5 through 6, I believe 5 through 6 or 5 through 8, they do not give us the picture. They just give us the letters, which is fine because we already know the equation. So in this case, a is 12, so we can say 12 squared. B is 5. And c is our missing piece. And we're going to do the same thing that we did in the problems before with pictures. Okay, 12 squared is 12 times 12, which is 144. 5 squared is 25. We're missing c squared. These two are on the same side, so I can combine those together to get 169. And then my final step, what is it? Yep, you got it. We have to take the square root of both sides to get rid of this squared here. We don't want that to be there. So we have c equals, and this one works out perfect. The square root of 169 is 13. So c equals 13. All right, in this one, we are missing b. So we can say 8 squared plus b squared equals 10 squared. 8 squared is 64 plus b squared, and 10 squared is 100. Okay, I want to get this b squared by itself, so I have to subtract 64 from both sides. So b squared, 100 minus 64 is 36. Okay, one final step. Go ahead and take the square root of both sides. So b equals, and the square root of 36, you can think to yourself, what times itself gives you 36? That's 6. Okay, so b is 6. All right, I would like you guys to pause the video at this point and try 7 through 9. I'm not going to go over these ones on the video, but if you have questions about them, you can email me. But pause the video, and in just a couple minutes, I will post the answers. You can double check to see if you are correct. All right, hopefully you're done your problems. You come back from pause. And for number 7, you should have b equals 8. For number 8, we have a is equal to 30. And number 9, we have a is equal to 3.5. And I did round that one, so you might have something that's similar to that. If you have questions about any of these 3 and you would like to see them worked out, you can join me on Blackboard Collaborate, or you can email me. Okay, number 10. This one is a little tricky because they want you to find a third number. So this one could have multiple answers, but let me show you how I would solve it. So looking at the first one, I have 9 and 41. 41 is the bigger number, so I'm going to call that one C. Okay, remember the largest number is always my hypotenuse. 9 could be either one of the legs, so I can call it A or B. I'm going to call it A in this case. Okay, so now I'm going to substitute those two numbers into the Pythagorean theorem. So I have 9 squared. I don't know what B is, so I'm going to keep that. But I do know C is 41 squared. Okay, so 9 squared, 9 times 9 is 81. plus b squared. And then if you grab your calculator, because this is going to be a big number, 41 squared is 1681. 1,681. All right, so we need to get our b squared by itself. So we're going to subtract 81 from both sides. And this one should be pretty easy. 1681 minus 81. We get b squared equals 1600. And then if we take our pen and we take the square root of both sides, the square root of 1600, b equals 40. So 40 could be the other side for the first one. All right, let's look at the second one. So again, 1385. 85 is the bigger one, so I'm going to call that C, and I'm going to call the little one A. So we have 13 squared plus b squared equals 85 squared. Don't forget those squareds on there. All right, 13 squared is 169. You can use your calculator or you can use that perfect square chart. We don't know what b squared is. And then you definitely need a calculator for this. 85 squared is 85 times 85, or you can use the 85 and the caret button too. And you get 7,225. Whew, that's a big number. All right, to get b squared by itself, we need to subtract 169 from both sides. Okay, so our 169s cancel out. And we have b squared equals, looks like 7,056. All right, final step. B is not by itself yet, so take the square root of both sides. That's always your last step. And you get b equals 84. Okay, and again, these numbers we're getting, they are not the hypotenuse. The hypotenuse has to be bigger than these numbers. 85 is bigger than 84. Okay. All right, let's take a look at the next one. So now we've gotten into word problems. And what I like to do for word problems, I like to draw a picture because it makes it a little bit easier. So this screen tells you that a right triangle has a hypotenuse of 13 and a leg of 5. So let's go ahead and draw a right triangle. It doesn't matter which direction you have it facing. We have a right triangle. The hypotenuse is 13 and one of the legs is 5. Again, doesn't matter which one it is. And we're missing this one over here. So let's go ahead and label our pieces. So I can say I know my hypotenuse is C, and then I'm just going to call my other ones A and B. So I have A squared, I don't know, plus 5 squared equals 13 squared. Okay. A squared, I still don't know. 5 squared is 25. And 13 squared is 169. Okay. All right. So in this case, we have to subtract 25 from both sides. So we have A squared equals 144. And that very last step is to go ahead and take the square root. So A equals 12. Okay. So again, when it comes to the word problems, draw a picture. It makes it a little bit easier to understand and try to label each part. All right, number 12. So this one, it says 2 joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile? They must travel to return to their starting point. So again, we need to draw a picture. And I always think of a compass. So if I'm thinking about a compass, I have north and south, and then I have east and west. And I don't know how you guys learned it, but I always went clockwise, never eat sour watermelons. That's how I learned it when I was in school. Okay, to remember which one goes first. So it says 2 joggers run 8 miles north. So if this is their starting point, we're at 8 miles north. Okay. And then 5 miles to the west. And I would just connect it back to my starting point. This is the side we need to know. So this is our 90-degree angle. All right, so if I go ahead and label my pieces, I know this missing piece is my hypotenuse, my C. And then it doesn't matter which one is A and which one's B. So I'm going to call A 5 and B 8. All right, let's go ahead and substitute these into our equation. So we have 5 squared plus 8 squared equals C squared. 5 squared is 25. 8 squared is 64. And C squared is our missing side. Okay, if I add together 25 and 64, I get 89. And then finally, if I take the square root of both of those sides, I get C equals 9.4 miles. And that makes sense because 9.4 is bigger than 5 and 8. Okay, so I like the word problems and I love the Pythagorean theorem because these are real life word problems. You guys ask all the time, when am I ever going to use this? And of all the things that we've learned so far this year, Pythagorean theorem is one of those things that you see all the time. Okay, so 13 through 15 are our challenge problems. You can do those on your own and you can email them to me to let me check them. Again, I recommend drawing a picture for each one of these. Be very careful. They are all multi-step problems, so it's not just as simple as doing the Pythagorean theorem and you're done. Usually there's another piece to it, especially number 14 and number 15. So make sure that you read it all the way and make sure you answer the final question. All right, your exit ticket is what is the length of the line segment with endpoints -1, 4, and 11, 9. This can be submitted to me through email, through the drive, or directly on Schoology. One of my hints for you is you have to figure out what is the distance between -1 and 11. Figure out how far apart are they. And then you need to figure out how far apart are 4 and 9. And those two lengths become the legs of your triangle. Okay, and you're trying to find the hypotenuse. So the distance between -1 and 11 could be your A, and the distance between your 4 and your 9 could be your B. And then use the Pythagorean theorem. So as soon as you're ready, go ahead and submit your exit ticket to me. All right, if you have any other questions, please email me or jump on my office hours link.